Okay, so looks like we're talking about this is number 11 on the sample test. It's number 11. And I'm going to give a little bit of solution here for it. So we got a sculpture suspended by 3 chains, each 3 meter long, attached to the ceiling at locations that form an equilateral triangle with sides of 3 meters, right? What is the tension in each chain? So basically, remember how these guys go for these chains. You're gonna have to basically figure out this angle from horizontal, okay, for a one of the chains, and then you can figure out the tension in it based on the fact that the force of gravity here is pulling in its y direction, okay? And so what you would do is this force of gravity would be equal to the tension that's pulling down on the thing here. And so you can kind of say that that vector, that downward vector, is here in a way. If I know I'm drawing a lot of vectors here, so what I'm basically going to do is this is the force of tension. It's got a y component, which is equal to the force of gravity. Okay. Now, before we had 2 chains, and so we divided it by 2, this force of gravity. But since in this question there are 3 chains, we're actually going to go ahead and divide it by 3. All right. So it's one. Each chain has to take 1/3 of the force of gravity. Okay. And so to figure out the force of tension in this, we basically say that the sine of that angle is equal to the opposite side, or the force of gravity over 3, divided by the force of tension in the train, because it's the opposite, and the hypotenuse, the opposite over the hypotenuse. Okay? And that's kind of what we're looking at, all right? And so so that leaves just one thing, is we have to figure out the angle. So I'm going to go ahead and, this is going to be a tough drawing actually. I'm going to go ahead and try and draw this. So you've got your sculpture here. It turned out to be pretty okay. And we've got 3, this is 3, each one of these is 3, 3, 3, right? Every one of these things is 3. All right. And so what we need to do is we need to figure out the angle at which these chains, these chains here, these chains here, the angle at which they make with horizontal. And so basically what I'm going to do is I'm going to draw like a dotted line like this. This is the center of that upper triangle, okay? And it's essentially right above the sculpture there, okay? And then what we've got is this angle here is the angle that we're needing in this scenario. So we're going to have to do a bit of geometry to figure that out, okay? All right, so basically I went ahead and paused the video so I could draw some of these faces out. In order to figure out that green angle right there, I went ahead and sort of labeled this thing. Okay, so we've got, I'll do it with the pointer, A, B, C, D is the this is a tetrahedron, right? And this is A, E, B. So this is basically like the part that's on the ceiling, right? The chains are attached here, here, and here. So this is the part on the ceiling, okay? Now I've got this blue triangle, which represents a triangle that goes right from the midpoint of one of these sides to the center of right above the sculpture, and then drops down to the sculpture. And then this is not a chain, but it's sort of like an imaginary line that comes in like this, okay? That goes from the midpoint of touching the ceiling here to the sculpture itself. Sort of, it actually bisects the chains here, all right? And so another thing you want to keep in mind, this AO right here, this one right here, that bisects AO, and then also BO, that bisects the entire bottom of the tetrahedron, okay? So you can kind of think of the entire tetrahedron as being like this, right? This is sort of the part that touches the ceiling as if you were hovering above it, okay? And these angles here, they bisect this 60-degree angle. Because remember, these are equilateral triangles, 3, 3, and 3, right? This length is 3, 3, 3. And so basically this will bisect it and go straight to the center, making that 30, making this 1.5, okay? So I'm going to write 2/3 or 3/2 here, okay? And now my goal would be to figure out this yellow line, all right? Knowing that that's 3/2 and that's 30 degrees, I can use the tangent function, okay, to figure out this yellow line, which is called EO, right? So I could write the fact that the tangent of 30 degrees is equal to the opposite side, which is EO over 3/2, okay? And there, I can figure out EO, all right? So now that I've got EO, which by the way, EO is the yellow line, so I'm going to kind of keep it yellow. So now that I've got EO, right, I am going to figure out, let's see, what am I going to figure out? I actually need to draw another triangle here. I'm going to draw triangle EBD, okay? Triangle EBD, all right? And let's see, is that what I'm going to draw? No. Wait, I've got EO here. Wow, this is, let's see, what was I about to do? I forgot, I lost my train of thought here. All right, so yeah, I was correct on it, or that's what I was doing. I was going to draw a triangle B, E, D, okay, and I'll draw it a little upside down here. So here's B, here's E, and here's D, okay. Now the thing about this triangle is this is 60 degrees, and this is 3/2 as well, or 1.5, okay. So I'm going to write that as 3/2. What this does is this actually is going to be able to give me ED, right? So therefore, I can write the following, that the tangent of 60 is the opposite, or ED, over 3/2, okay? So now I have ED, which is this line right there, ED, okay, ED. So if you look at that, I currently have E, D, and EO. And so therefore, I can figure out, oh man, I need another color. Let's go with purple. I can figure out this, OD. Okay, so I need another, there it is, OD. I had that one already, OD. Okay, and so I have ED. I've got, oh, there's ED right there. Okay, and there's EO. And so now with the Pythagorean theorem, I'm gonna go ahead and I guess I'll do this in whatever, blue or something like that. I'm gonna say that EO squared plus OD squared should equal ED squared. ED is 3 tangent of 60 over 2. And by the way, let's think about what the tangent of 60 is. Remembering that 60 is the square root of 3 over 2 and 1/2, and so it's actually the square root of 3 over 2 over 1 over 2, which is equal to the square root of 3. It's the tangent of 60. And the tangent of 30 is, well, the reciprocal of that, because 30 has a 1/2 as its opposite side and a square root of 3 over 2 as its adjacent side. And so it's 1/2 over the square root of 3 over 2. And so basically the tangent of 60 is the square root of 3. Tangent of 30 is 1 over the square root of 3. So I'll write that down. Tangent of 60 is root 3. Tangent of 30 is 1 over root 3. Okay? And so now ED is, I'll write that here, I suppose. ED is the square root of 3 times 3 over 2. Okay? EO is 3 over 2 with the square root of 3 on the bottom, or times the tangent of 30. So it's 3 over root 3 times 2, or 2 root 3, I guess I should write. I'm going to write 2 root 3. Okay, so that's that one there. Now, those are the ones, EO and ED. Those guys get placed here. And so I'm going to go ahead and figure that out. So EO is 3 over 2 root 3. This is squared plus OD squared equals ED, which is 3 root 3 over 2 squared as well. Okay, and now if we figure all this out, this is 3, or I guess I'll square them. So it's going to be 9 over 4 times 3, so 9 over 12 plus OD equals squared. Sorry, that was squared. And this is 9 over 4 times 3, so it's 9 is 27 over 4. Hopefully I got that right. And so I'm going to go ahead and subtract 9 over 12. So OD is 27 over 4 minus 9 over 12. Both of those go into 4. 3, actually. Divide 9 by 3 and I get 3. And divide 12 by 3, I get 4. So that's actually kind of cool. Giving me an equal to 27 minus 3 is 24 over 4. Oh, is that 6? Is that the square root of 6? It's the square root of 6. How about that? So OD is the square root of 6. Huh. That's purple. Square root of 6. Okay, so now that we know that that is the square root of 6, I'm going to pull out one last triangle here. And that is, wait for it, A, O, D, right? So let me do that. A, O, D. And guess what? That's the triangle with my green angle that I've been waiting for all this time. And I have OD, which is the square root of 6. I have AD, which is 3. And so I can figure out that angle. Look at that. Because the angle is, what is the angle here? It's going to be the opposite and the hypotenuse. So the sine of that angle is the opposite, or the square root of 6 over 3. Okay? And so I'm going to go ahead and do sine inverse of root 6 over 3 is my little fancy angle. All right, and I don't know what that is, but I'm going to try it out, and then we'll see what happens. Let's do sine inverse of, send it into the calculator here, root 6, close parentheses, divided by 3. We're getting a 54.7 degrees. So equals 54.7 degrees. How about that? So we're going to go way back up here, and we'll plug that into this thing. I'm going to erase this. We'll plug that into here, and that green angle is 54.7. So therefore I've got the sine of 54.7 is equal to the force of gravity, which is 240 over 3 over the tension force, right? Force of gravity is 240. And there you go. We solved it. The force of tension is 240 over 3 over the sine of 54.7 degrees. And there you have it. That's the force of tension. You can plug that into the calculator there. Anyway, this was a pretty cool little question in terms of like how to solve how to look at the geometry of a tetrahedron. Kind of fun.